Today's topic is NCERT 12th Standard Physics, exercise problem 2.23. So the question 2.23 is, an electrical technician requires a capacitance of 2 microfarad in a circuit across a potential difference of 1 kilovolt. That means this electrical technician wants a capacitor 2 microfarad, and this capacitor must withstand a voltage of 1 kilovolt. This is the requirement by the electrical technician. A large number of 1 microfarad capacitors are available to him. That is, he is having only 1 microfarad but large numbers. But he don't have 2 microfarad with 1 kilovolt rating. So, but he has a large number of 1 microfarad capacitors are available to him, each of which can withstand a potential difference of not more than 400 volts. That is, he has large number of 1 microfarad. That means he has a capacitor 1 microfarad which can withstand the voltage of 400 volts maximum. But what's the requirement? The requirement is 2 microfarad 1 kilovolt, but he doesn't have this component. But 1 microfarad which can withstand 400 volts, he has large in number. Suggest a possible arrangement that requires the minimum number of capacitors. So with the minimum number of capacitors, we should be able to build a 2 microfarad capacitor with a voltage rating of 1 kilovolts. This is the question. Now we will try to solve the problem. Okay. Now the requirement is, we want 2 microfarad capacitor with 1 kilovolt rating. First, what we have is, we have a capacitor with 1 microfarad. Voltage rating is 400 volts. So, first we will increase the voltage rating. So, suppose if I connect first capacitor, forget about 1 microfarad. This will have 400 volts. Then you add one more capacitor. This will have 400 volts. And another capacitor. This will have 400 volts. So altogether it will be 1200 volts. If you connect only 2, it will be 800 volts. Then the requirement of 1000 volts, we cannot get 1000 volts. But here we can get, it can withstand 1200 volts. It's okay. But only thing is, it should not be less than 1K. That's the idea. Okay. Now, now you have 1 microfarad here. 1 microfarad and 1 microfarad. All this will withstand a voltage of 400 volts. 400 volts and 400 volts. Okay. Now these capacitors are connected in series. So you all know that when 3 capacitors are connected in series, 1 by Ct, all are same value, 1 by C plus 1 by C plus 1 by C. That is 1 by Ct is equal to LCM is C, 3. Therefore, Ct by 1 is equal to C by 3. That means the equivalent capacitance between this point and this point is C by 3. That is C by 3. That is 1 microfarad here, which is equal to 1 microfarad divided by 3. Now, how many sections we have to connect? So parallelly voltage will be same. So 1 by 3 microfarad into X should give us what? 2 microfarad. Okay, that is X is equal to 3 into 2, 6. That means we should connect 6 sections. Okay, let us see how to connect these sections. So this is first section, then you connect second section, So all are 1 microfarad. They all are 1 microfarad, 400 volts. 400, 400, 400, 1200. Here also 1200. But here all the three capacitance are series. This series connection is connected in parallel. So the number of sections you have to connect is 6 sections. This is second section. Then you have third section. Then you have fourth section. Then you have fifth section. And then you have sixth section. Okay, now this is between this point and this point. I'm calling this as A and B. So if you connect 6 section, this section is parallel with this section is parallel with this. So for this series section it is 1/3. So totally we have 6 section, that is it has 1/3 microfarad, but in parallel connection we have to add into 6. That is, this will give you what? 2 microfarad. So between A and B, if you see, and if you connect all these 6 sections, you will get 2 microfarad. Okay, now this is 400, this is 400, this is 400, so 1200 volts. You all know that in parallel connection voltage will be, because if this is A, this is B, this is also A, this is also B, so all are connected in parallel. So this can, as it is, you are getting between A and B, you are getting 1200 volts. You may ask that they have asked for 1000 volts, why we are getting 1200? Because if we connect 2 capacitors, we get only 800. But the important point here is, if the given voltage 1000 volts, if it is higher than that, that means the circuit, the capacitance is safe. So that 1200 volts it can withstand, whereas here it withstands only for 1000 volts. Okay, that's the advantage. So this is the minimum connection we can give. You can add one more capacitor in all the sections, still you can get this voltage to be more, and still you can get 2 microfarad. But what the question is, they have asked for, suggest a possible arrangement that requires a minimum number of capacitors. This is the minimum number of capacitors we can have. So how many capacitors is required? All are 1 microfarad. All 1 microfarad. 1 microfarad. That means 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. That is 3 into 6, 18. The requirement is 18 capacitors. Capacitors of value 1 microfarad, 400 volts. So you have to connect in this fashion all the 18 capacitors, and all are 1 microfarad 400 volt. And if you connect in this fashion, then between this point A and B, you will get the effective value as 2 microfarad, and the voltage rating is, it is not 1000 volts, you will get 1200 volts. This is the minimum possible way by which we can give the connection. And that's the answer for the problem, question 2.23, NCERT 12th standard physics. Thanks for watching. Thank you. Nandri.